Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. And it's called Minimality. Minimality. Yes, minimal. It. Okay. By Andrew Sarkis or Sarchis. And here, I'm having problems saying things right now, I guess. But let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have disjoint groups, where cells with the same relative position within their box must not contain the same digit. So there are no repeats in cells in the same position in boxes. So that means in all of these cells, there must form a unique set of the digits you have to have complete set of the digits 1 through 9 in these 9 cells. So say you had a 9 here, that means in none of the other blue cells could you have a 9. Because again, you have to the cells with the same relative position within their boxes must not contain the same digits. So it also works for these 9 cells here. These form a set that contains the unique digits 1 through 9. Same with this, etc., etc., right? So this is also a unique set that contains the digits 1 through 9 exactly once each. So that's an example of how disjoint groups works. We have Renbands, where digits along a purple line form a non-repeating set of consecutive digits in any order. So you could have something like, say, 2, 5, 4, and 3 here, and this would be valid because this forms a set of a non-repeating set of consecutive digits, right? 2, 3, 4, and 5 are consecutive. What you could not have is something like 6 here, because 2, 3, 4, and 6 is not a consecutive set, or set of consecutive digits, I should say, right? Because there's a gap between 4 and 6. And that's an example of how Renbands work. We also have minimum, where digits in minimum gray cells must be strictly smaller than each of their orthogonal neighbors, which means that any cell that is a minimum, which are these cells which have arrows pointing inwards, they must be less than all the digits which share an edge with it. So as an example, you could have something like, say, 3, 4, 4, 7, and 8. And this would be valid because this 3 is obviously less than all 4 digits that it shares, or all 4 cells that it shares an edge with. This could not be, say, like 2, because 2 is obviously less than 3, and it's not greater than 3, which it must be. 3 is not less than 2, I should say. That's probably the easier way of putting it. And that's an example of how minimum works, which is why this is called minimality, but it's also probably called minimality because this is probably a minimum amount of clues you can have to still solve this puzzle. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the first thing that comes to me is the upper left-hand corner of the box, of each box. 7 of them have minimal rankings, which means they are guaranteed to be less than at least 2 other digits. So since 7 of those are the case, that means the other 2, so to be less than 2 other unique digits, right? This is less than 2 unique digits. This is less than 2 unique digits. This is less than 2 unique digits. Less than 2 unique digits, less than 2 unique digits, less than 2 unique digits, and less than 2 unique digits. That means to be that way, you have to be 7 or less, right? 8 is only less than 1 digit, 9 is less than 0 digits. So that means these upper left-hand corner minimals must be 1 through 7. From the disjoint set, we know then this has to be 8, 9 as a pair. And to make this a Renban, it has to be 6 and 7 with it. So that means 8 and 9 is here. This is 6 and 7. So this must be 1 through 5 here. We don't know where the 7 actually is. Well, we have some clues. This is 8 or 9. So this, if this were 7 here, that would guarantee it'd have to be between 8 and 9 in the vertical or the horizontal. And this cannot be 8, 9 because we have a guaranteed 8 or 9 here and a guaranteed 8 or 9 here. So this cannot be 7. So this is 1 through 6 at most. This could be 7, though. So 7 could be any of these, because we could have 8 and 9 there. Okay. Remaining digits in box 5 have to be 1 through 5, and then 8, 9. Okay. This digit obviously cannot be 7 because it has to be less than, if it were 7, it would have to be less than 8 and 9, and that would eliminate all possibilities for that cell. So this is at most 6. These can never be 1 surrounding any minimal cell. That's interesting. Does that tell us anything? I'm not sure. Maybe? None of these can be 1. Wherever 7 is in the upper left-hand corner, we are guaranteed an 8, 9 pair in those two cells that are in the same box. Does that tell us anything? I'm not sure if it does. Maybe, maybe not. Huh. Interesting. Okay. If we have a 5 here, that would guarantee that these two digits have to be 8 and 9. Right? Because 6 and 7 have to be here on the Renban to make this a set of consecutive digits, because we're guaranteed both 8 and 9 there. To form a 4-length Renban with 8 and 9, you have to be 6, 7, 8, and 9. So if this were 5, that would guarantee this is 8 and 9 as a pair. And the 7 has to have 8 and 9 in that situation too, which would mean we would have all the 8 9s already accounted for next to this 5 and the 7. But then that means 6 in the same position would have to have 7 and 7 next to it, which is obviously a contradiction. So this cannot be 5 here. So we are guaranteed. So 7 must have both 8 9s next to it. 6 has to have a 7. I guess it could have both 8 9s guaranteed next to it. Interesting. Huh. Um, let's just do around the, okay, what, around the minimums, let's sort of mark where you cannot have ones. Maybe that'll be helpful. Um, these cannot be ones. Hmm. This cannot be a 1, because then that would force this to be 2, and then this digit would have to be less than 2, but the only digit that's less than 2 is 1. So this cannot be 1 here. So 1 in row 1 has to be on... Oh. 1 in row 1 has to be in one of the minimums, which means we cannot have a 1 in any of those other minimums. So this cannot be 1. This can't be 1. So therefore, these cannot be 1 as the minimums here, right? This can't be 1, obviously, and these can't be 1. That's interesting. This can't be 1. Huh. So we also have ones that you can't have 2 in, which is interesting. This is less than 3 unique digits, right? Because it's in the middle. So it's less than 3 unique digits, so it has to be at most a 6. But this could be 1 here. Okay. Ah, but it can't really be 6. If it's 6, that would force this to be 7, 8, 9, but this digit would have to be consecutive with that one, which means it would have that digit would also have to be larger than this digit here. So this can't be 6. So we have these 4 digits are larger than that digit. Um, hmm. So I do we start layering on what cannot be 2? Hmm. Maybe. Okay. I guess we'll make him pink. It's not very many, I guess. Hmm. Not too helpful. So this must be less than this, and it cannot be 1. So this is 3, 4, 5, 8, and 9. Hmm. Hmm. What else do we have? 1 then. Okay, that's interesting. 1 in row 4 has to be here or here. Okay. 1 in column 1 is either here or here. Hmm. 1 in column 4 is here, here, or here. That's fine. Um. Hmm. Oh. Okay. In column 1, 1 has to be in the upper left-hand corner or the lower left-hand corner. In column 4, 1 has to be in the upper left-hand corner here, upper left, sorry, that's upper left, and then, or the bottom left corner in these two cells, right? That means we are guaranteed one of them has to be in the upper left-hand corner and one of them has to be in the lower left-hand corner for columns 1 and columns 4. Which means column 7 cannot have 1 in the upper left-hand corner and cannot have 1 in the lower left-hand corner. So neither of these can be 1, which means this has to be a 1 there, which means this can't be 1, obviously. Right, because 1 has to be in the left central position. 1 has to be there, right? You have to have all the digits from 1 through 9 by disjoint sets rules. None of these can be 1 because they all have to be greater than a minimum here, right? This is greater than a minimum. So we're guaranteed this is 1. Interesting. That means we need something similar for the upper central position. These can't be 1 because they're greater than a minimum. This is greater than a minimum. This is greater than the minimum, greater than minimum, greater than minimum, greater than minimum. So this must be a 1. Okay, so therefore 1 cannot be here. What about upper right-hand corners? Okay, so in row 7, oh, neither of these can be 1. In row 4, since 1 is here, that means none of these could be 1. So in the upper right-hand corner, where can the 1 be? These are greater than minimum. This is greater than minimum. This is greater than minimum. This can't be 1 because of 1 in the box. So this has to be 1 here. Okay, which means this is 1 or this is 1. This is 1 or this is 1, which means we guaranteed have a 1 in one of these two cells. This can't be 1 because of 1 in the box, so this must be 1 up here. So this is 1, which means this can't be 1 here. This has to be 1 there. So we have upper left, left central, lower left. We have upper central. We don't have central central. We need bottom central. So this could be bottom central. Okay, so one of these two is a 1. We're not sure which. In box 3. That means one of these two is a 1. And one of these two is a 1. Okay. So, for the lower right-hand box, it is either 1 here or 1 here. For the lower central box, it could be here, or lower central cell, I should say. Here, here, or here. Hmm. If this is 1, this would guarantee this is 2 and 3, which is possible. Oh, this has to be then pink. Because it cannot be 1 in there. Oh, so then these are pink. These are pink. Because this can't be 1. Um, yeah, maybe we can remove the reds now because that's sort of, or maybe we just remove all the pinks. So then the reds, the one places where you cannot have two are as everything but the one surrounding the one. This could be two also. Okay, yeah, we know that. This could be two, this could be two, and this could be two now. So the also the minimums. Okay. That means in column, okay, there we go. In column one, the twos has to be in a minimum, which is in the upper left-hand corner, which eliminates two from upper left-hand corners in general. So this can't be two, this can't be two, this can't be two. So we have 3 through 6 here. And then we'll mark these as pink, I guess. We have pink, pink. So therefore, this can't be 3 here to be next to that 2. So the pinks are now the places that can't have 3 in them. So 2 is one of these 3. Okay. Um... Where is 2 available? Well, this could... Okay, so this can no longer... This does not have to be red. So in the upper central cell, where is the 2 possible? It could be here or here. Right? Because all of these are next to minimums, which have to have a minimum of 2. So therefore 2 cannot be next to them. But 2 has to be either here or here. Okay. What about left central positions? This could be 2. No, this cannot be 2 because this can't be 1. Therefore, that doesn't work either. So left central positions, none of these can be because 2 has to be in one of the minimums here. Can't be here because of same problem. It could be here. Oh, in fact, okay, can't be here. Same problem, can't be here. This is a 1, so obviously can't be there. Can't be here because it's greater than a 2 at least, so can't be there. So this must be 2 here, which means this cannot be 2, which means this has to be 2 here, which must be greater than 1. So that's 1, which means this can't be 1. This 1 eliminates 1 being there. For the lower right-hand box, 1 has to be here. Or lower right-hand cell, it has to be there. This 1 eliminates 1 here, so therefore this is 1 there. And now we have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. We need the last 1, so it has to be there. We have 2 there. So we have all the positions of the 1s. So for 2, again, we have lower left. This cannot be 2. So we have upper right. Or upper central, sorry. Sorry, this is left central. Ugh, I don't know. I got mixed up there. We need lower right for 2. Can't be any of these. It could be, this can't be 2 anymore, so it cannot be there. So 2 is one of these 2. So this cannot be 2, which means this is pink again. So these are all pink, I guess we should say too also. Interesting. Where is, well, never mind. So this is 1. We have 2 here. We need lower left positioning. So it's either here or here. Okay. One of those is 2. That's fine. 2 cannot be here. Wait, this could be 2. Right. That could be 2. So that's not red there. Okay. So 2 could be there or there. 2 cannot be here. Where is 2 in column 9? It's either in the upper right-hand cell or the lower right-hand cell, right? Because it can't be any of these, can't be here, and can't be here. Okay, so we have guaranteed 2 in one of these scenarios. So these positionings are not changed, right? There is no positioning for the cell here being 2, so this is guaranteed to be 2, which means this can't be 2. Well, where is a 2 in the upper central cell? It has to be here, which makes that 1. But these are not guaranteed. These could be 2 here. Okay. Two in box 8 has to be one of these 3. Okay. We have 2 here. 2 in box 5 has to be one of these 2. That's interesting. This 2 eliminates 2 here, which means these are pink also. Interesting. So 2 is either here or 2 is there. 2 in box 4 has to be one of these 3. Um, Where is 2? Two could be here. 2 could be here. Um, hmm. So this has to be at least 3. 3 through 7. That means it's 4 through 9, 4 through 9, 4 through 9. Hmm. Huh. Um, so obviously this can't be 2 anymore. None of these can be 2. I don't know if that helps. This can't be 2. This can't be 2. None of these could be 2 here. Okay. Hmm. What's interesting is if this is one of these is 2, right? Hmm. So one of these 4 is a 2. One of these 4 is 2. One of these 3 is 2 here. One of these 4 is 2 there. Obviously, if this is 2, this has to be 2 there, because this 2 eliminates 2 as a possibility there, so the only 2 left possible in column 1 is there. So if this is 2, this has to be 2, and these can't be 2, so this is 2. So then this would have to be 2 and 3. This would be 2, 3, 4 in that case. One of these would be 2. Hmm. Hmm. Um. Hmm. In column 5, you cannot have a 2 here. None of these can be 2 because this is on the red band with 8 and 9, and this has to be greater than at least a 3. This is a 1. This has to be greater than 3. So 2 has to be in the central position, which means we cannot have 2 anymore in the central position in any other column. So this cannot be 2 here. We're guaranteed a 2 in one of these spots. That's interesting. Um, hmm. Uh, hmm. Um, hmm. What else do we have? Hmm. Um, hmm. What else do we have? Hmm. Um, do we try pinks? Is that helpful? Hmm. Yes, that might be helpful. Okay, let's look at pinks. So this is greater than at least 3. This is 8 or 9. This has to be greater than 3. So in column 4, the 3 has to be in the upper left-hand cell or the lower left-hand cell. In column 7, it's the same, right? This is greater than 3. So, okay, we need central 3s, I guess, is the question. Left central 3s. This can't be left central. This can't be left central. This can't be. This is filled. This can't be. So left central 3s have to be, cannot be here. It has to be one of these two, which eliminates left central 3s in the rest of the column. So none of these can be 3 here. So this cannot be 3. That means in the upper left-hand corners, the 3 has to be either here, here, or here. Okay. So this is 4, which means this cannot be 4 next to it. It's 4, 5, 6, or 7, right? So one of these is 2. And then the 3 has to be next to it. That's interesting. So if this is 2, this has to be 3 next to it. If this is 2, that has to have 3 next to it. So we're guaranteed a 3 in one of these two cells in row 2, which means these are all pink because they cannot be 3 anymore. This could be, yeah. 2 is still pretty varied. Okay, what happens if we have a 2 here? If we have 2 here, that forces this to be 3. This can't be 2, so this is 2. This is 3, 4 as a renbin, so that's 4 and 3. Neither of these are 3, therefore this must be 3 there. This can't be 2, so this is 2 there. That's 3. That seems okay, right? Not 3 or 4. It's 5 or 6. This can't be 3. 2 eliminates 2 here. None of these can be 2. So one of these is 2. This is 2. Yeah, it seems fine. 3. We have a contradiction. So we have to have 3 here, 3 here. Where is 3 in column 7 then? It cannot be here because of 3 in the box. Can't be here because 3 in the box. This can't be here because that would be 8 and 9. So then this would have to be 3. But the 3 is not going to be greater than 5 or 6. So that's not going to work if we had this being 2. So this cannot be 2, which means this can't be 3. So this must be 2. There's no other place for it. I guess one of these is 2. That's interesting. So one of these is 2 here. One of these is 2. Huh. Right, so this could still be 2. So this can no longer be 2 anymore. So one of these is 2. One of these is 2. What happens? Well, Right. Not either of these could be 2. So in box 1, we have a 2 in the upper left-hand cell or the upper right-hand cell. In box 3, we have 2 in the lower left-hand cell and the lower right-hand cell. Okay, in column... Well, we already know that. So that's 3 and 3. That doesn't help. Column 7, 3 has to be one of these 3, right? Obviously, if this is a 3, that means neither of these can be 3, so this would have... One of these 2 would have to be a 3 here. This is 4 through 9 here. 4 through 9. Hmm. Hmm. Um... Let's move. Let's remove the reds and pinks again. The reds are getting a little bit confusing. We know 2 has to be one of these 2. We know 2 has to be one of those 2. This could be 2 in a lot of places. Okay, in row 1, we are guaranteed 2 in the upper left, upper right. In box 3, row 3, it's bottom left and bottom right. Box 9, it's one of the 3 corners. Here, not upper left. Column 5, we're guaranteed a 2 in one of these 2 spots. These are also 4 through 9. Huh. Huh. What happens if this is 2? So say this was 2. That would eliminate 2 from being here, so that would force that to be 2. None of these could be 2, so this would be 2 here. That would force a 2 here, so this couldn't be 2 anymore. That would force 2 to be there. And then we require 2 there, and then 2 there. So then this would be 3. This could not be 3, it would be 4, which would make that 3. So then you could have not 3 in these two, so therefore 3 has to be there. Let's see. And then we have a problem. We have a contradiction because we'd have to have 3 in one of these spots here, which is not allowed. So this can't be 2, which means this is 2. Okay. Yeah, that was I don't know. I'm not sure how you're actually supposed to figure that out without just plugging in digits. Okay. Well, we have 2 here, which eliminates 2 in one of these two. Two cannot be here. So 2 in box 7 has to be one of these 3. If this is 2, that would force this to be 3. So 2 would not be here, so 2 would have to be here, which eliminates 2 from being here. So then this would be 2, this would be 2. This would be 2 and 3. And this would have to be 3 and 4. This could not be 3 because of 3 in the row, so this is 4, that's 3. And then we have the same problem. So, because 3 cannot be either of these cells, because it's 8 or 9, or it's greater than 3, which is not possible. So, this can't be 2 here, which means we are guaranteed one of these two is a 2, which eliminates 2 from being there. Where's the 2 in box 9? It must be one of these two, so this can't be 2 here, therefore this is 2 here. Okay, that was interesting. Hmm. So part of the question, though, is what happens if this is 2? I think this Renban has been pretty restrictive. So if we have 2 here, that forces this to be 3, 4, which means this can't be 3 or 4. This is 5 or 6, which means this can't be 4 or 5. So 2 here forces this to be 2. We have 5, 6, so this can't be 4, 5. This can't be 4, 5. So 2 here means 2's here. 2 can be one of these two. It's not that restrictive there. Okay. In row 4, 3 has to be either in the upper left-hand corner there or the upper right-hand corner here. Do we have another restriction like that? Not particularly. We do kind of have a restriction in row 2? Wait, why is this pink? I can't imagine why that would be pink. Or this one either. This doesn't seem right. Yeah, that doesn't seem that restrictive. Neither does this, actually. Why is that pink? I don't know why. So these are pink, which they are valid. I don't know why that's pink either. So this can't be 3. This can't be 3. No 3 around here. Wait, this could be... That can't be... Why can't that be pink? Oh, wait, hold up. We have... Right. Okay, so this can't be pink. Right. That makes sense, right? Because we have a guaranteed 3 in the left central box, or left central cell. And it has to be one of these two then. That makes sense why that's pink. Oh, so we guaranteed a 3 here. That's interesting. Which means this is pink. Right. Not too restrictive. Can this be 3? This cannot be 3. So this is 2, 4, 5, 6, 7. 2, 4, 5, 6, 7. Um... Hmm. Hmm. Can this ever be 3? If this were 3, that would force this to be 2, which would force 3 to be below it. So the answer is no. So this is pink, interestingly enough. If this was 2, same problem, right? If this is, if this is 3. If this is 3, that forces this to be 2, which would have to have the 3 below it to satisfy disjoint sets. So this can't be 3 either. That ain't too helpful. Where is 7 in the upper left-hand corner? It cannot be these two. Well, why can't it be this one? Could be. It can't be this one. Why can't it be that one? You'd have 7, 8, 9 as a pair. This is 8, 9 as a pair. Okay, I don't know why I removed 7 from there. That could be 7. Yeah, I don't know how I removed that. That was weird. Oh. Interesting. Where are 6 and 7 in column 4? None of them can be here. Can't be this. So one of these two at least has to be 6 or 7. So this can't be 4 because that would force this to be 3 here. Can't be 5 because that would force this to be 3 or 4. But again, we have to have one out of the 6 or 7 must be in one of these two. So either this is 6, which could make that 3, 4, 5, or it's 7. Why can't this be 7 again? Oh, because you can't have 8 and 9 there. So this definitely cannot be 7. So we're guaranteed a 6 or 7 here, and it could be both. So it could be 7, 6 there. And this is obviously greater than 3. But that doesn't tell us much. 3 in box 8 has to be one of these 3 cells. Does that help us any? Not particularly. Well, this is the cannot be 3, right? So this has to be one of these has to be orange, but that doesn't help anything. Um, hmm. Okay, how many digits can these be next to? We have 1 and 2. Upper central box. Where are the 3s? Upper central cell. Cannot be here, cannot be here, cannot be here. Can't be here, can't be here. Could be there. Ooh. Dang it, I thought I had something. So it has to be, 3 has to be one of these 3. Oh. Okay, where is 3 then? On the upper central cell. If we try to have a 3 here, that would guarantee 2 is here. But again, we need a 3 somewhere as the left central cell. So if we try to have 2 here, there's no place for 3 to have a left central cell because 3 would be here. Same with this. If this is 3, that forces this to be 2, but this can no longer have 3 there, and this can no longer have 3 because this can't be 2, which means it has to be greater than it. So 3 could not be there either as the upper central cell. Where can it be then? It has to be here. So this is 3, which eliminates 3 from being here. That was cool, actually. So 3 has to be here, which means the central cells can't be 3 here. This could technically be 3. So these are orange. 3 is here. 3... Why can that not be pink? Oh, because one of these is, yeah, 3. Huh. Okay. Um... Huh. 3 cannot be then here anymore. Where is 3 in row 7? It has to be one of these 2. Interesting. Hmm. So 3 has to be either here or here. That's interesting. Where can it be in the... Okay, so... In row 7, 3 is in the upper left-hand cell or the upper right-hand cell. In row 4, 3 is in the upper left-hand cell or the upper right-hand cell. Which means we cannot have... Okay, so this can't be pink anyways. Okay, well, yeah, there you go. Yeah, we already restricted that, so that wasn't that helpful. We do know one of these two is a 3, though. Right? This can't be 3. These can't be 3 because they're greater than 3. These are greater than 4, so they can't be 3. So 3 has to be either here, and then we prove that this cannot have a 3 in either of these cases. So 3 has to be one of these two. Well, we're guaranteed a 3 in one of these, which means this cannot be 3 here. This can't be 3 either. So in box 7 or 6, 3 has to be one of those two. Interesting. In box 3, 3 has to be one of those two. Huh. Okay. Three could be any of those four. That seems fine. So these are 5 through 9 here. If you have 3 here. Huh. Okay, let's try. What happens if we have 3 here? If we have 3 here, this is 4. 3 eliminates 3 from being here, so that's 3. This is 4. So that can't be 3, therefore this is 3. That seems okay. This can't be 3 anymore, so this must be 2 and 3 there. Interesting. This can't be 4, so these can't be 5. No, 2 or 4 here, so that's 5, 6, 7. So this can't be 2, this is 2 here. This has to be 6, 7, 8, 9. This is 2, 3, obviously. 3 can't be here, 3 can't be here. 4 is here, so this can't be 4. This can't be 4, so these can't be 5. 3 is one of these two. 3 is also one of these two. No 4 remaining here. This seems okay. So 3 is one of these two. 3 is one of these two, which means this cannot be 3, so 3 has to be here, which makes that a 3. That seems fine. This is also 6, 7, 8, 9, so this must be 4 here. This can't be 4 here. No 4 here. This is 3, so this cannot be 2 here, so that forces 2 to be there, which makes that 2. That seems fine. That means this can't be 4 here. There's a 4 in the corner. Three, 3, 3. Yeah, that seems fine. So that's not leading to any contradictions here. Okay, what happens if this is 3? If we have 3 there, that's 2. This has to be 3 there, which means this can't be 3, so that's 3, which means that is a 3 there. This is 2, 3, and 4, so this cannot be 3 or 4. Therefore, this can't be 4 or 5, because they have to be greater than 5 or 6. Where is 4 in column 7? It has to be here. So this is 4. Oh, that's interesting. So if this is 3, that's 4. If this is 3, that's 4. So we're guaranteed one of these two is a 4. Huh. Okay. So then, okay. This is guaranteed to be 4, which eliminates 4 in the rest of the row. So let's just go through that again. So this is 3. That forces this to be 2. That's 2. This is 3, which makes that 3. That makes that 3. This can't be 3 anymore. So this is greater than that. This has to be 4. That eliminates 3 and 4 here. This can't be 4 and 5 because it has to be greater than 5 or 6. This is guaranteed to be 4 here. So this is 2. We have 2 and 4 in this situation. That's interesting. 4 cannot be here. This is greater than 2. And it cannot be 3 or 4, so it's 5 through 9 there. That seems okay. Hmm. 3 eliminates 3 from being here. Does that help? I don't know. Three is one of these two. Okay. 3 is here. Three cannot be here, so 3 has to be here, which means we have one of these is 3. Four can't be here. Can't be any of these, so this must be 4. That's interesting. So that eliminates 4 from being there. No 4 there. This looks like it works too. This is 5, 6, 7, 8, 9. One of these is 5, so that means this can't be 5. 4 could be either of these spots. Yeah, this seems fine. Okay, so that's not helpful. Huh. The only thing we learned is that 4 has to be one of these two cells, because either this is 3 or this is 3. Right, we might have to go back to the upper left-hand corner and see what... So 7 is definitely less than both 8 and 9. So we're guaranteed one set of 8 and 9 in these two cells. In those two cells in disjoint sets. 6 has to be next to... Could be next to both 8 9s. Or 7 with one of the 8 9s. Okay. So that's not too helpful. Okay, where is 4 in the upper central cell? Cannot be here, because of one of these has to be 4. Can't be here, can't be here. Could be, can't be here. Could be one of these 3. It has to be one of those 3. But we don't know which. Yeah, we might have to get rid of the pinks too now. Huh. Interesting. Okay. So what does happen if this is 3? If this is 3, that's 4. That means this can't be 3. So that's 3. This is 4. So this can't be 3 anymore. So this can't be 2, 3, 4. This is guaranteed to be 3 there. So that would be 2 here, 2 here. Well, again, these cannot be 4 anymore. This is obviously 4. No 4 here. So no 5 here. Um, 4 cannot be in the upper central cell here. Cannot be the upper central cell here. So there's no 4, which means this can't be 5 here. So 4 has to be in the upper central cell in one of these two cells, which means this cannot be 4. This 4 eliminates 4 from being here. So we have 3 as one of those two. This can't be 4. That seems okay. Interesting. So this 4 is guaranteed to have a 5. Well, it cannot be both 8 and 9s because of the same problem that we had earlier. So the 5 is guaranteed to be here. Because if you have both 8 and 9s here, you have the 7 having the 8 9s surrounding that. And then the 6 can only have the 7 and none of the 8 9s if these were both 8 9s. So this is guaranteed to be 5 in that scenario. So you're not guaranteed. So you cannot have 8 and 9 remaining in the cells that are not next to the 7. That's interesting. Maybe this is not the best approach. I don't know. Let's see. So this cannot be 4, 5, 6, 7 in that instance. Can't be 4, 5, 6, can't be 5, 6, 7, because that would eliminate all possibilities for these cells. So it would have to at least be 6, 7, 8. So we're guaranteed an 8 along this string, if that's the case. Interesting. So then this would either... So this red band's either 2, 3, 4, or it's 6, 7, 8, or 7, 8, 9. Huh. So either this is 2, 3, and 4, or we have 6, 7, 8, or 7, 8, and 9 here. Huh. Okay. Does that help? I don't really know. Hmm. What else could we have? So 3 is one of these 3. Oh, 3 cannot be here because of 3 in the column. So we are guaranteed a 3 in one of these two cells here. Huh. That means we have a 3 guaranteed in one of these two cells. We have a 3 guaranteed in one of these two cells. So where is the 3 in row 8? It has to be one of these 3. Okay. Alright, we want to remove the pinks. Right, because we pretty much have the information. I guess one of these are 3s. Um... Hmm. This cannot be 3. If this were 3, that would mean this can't be 3, so this would have to be 3. But then that would force this to be 3. And there would be no 3 possible. So the possible 3s are in the lower central cell. Is this one and this one. So if there's a 3 here, that would eliminate 3 being there. It would eliminate 3 being here, which would force 3 to be there, which would eliminate 3 being here. So that's not possible. So this cannot be 3. What happens if we have 3 here? So if this is 3, that eliminates 3 from there. So this must be 3 here, which makes that 3. So this can't be 3. That's 3. Which means this can't be 3, so that's 3. This is 2, 3, 4. This is 3. That means this can't be... This is 3. That's 2. That's fine. So that's fine. This can't be 3 or 4. So this can't be 4, 5 here. Therefore, 4 has to be here. So this is 4. That's 4. This can't be 3, so where's 3 in row 4? It has to be there, which eliminates 3 in these cells. So 3 has to be there, which would force this to be 3. No more 3 here. 3 has to be consecutive with 4, so this is 4, which eliminates 4 in these cells. So this is 5 or 6 next to these cells. We have a 6, 7, 8, 9 quadruplet, and we have a contradiction. This was kind of convoluted to find that contradiction, but okay. So this can't be 3. There's probably a more elegant way of finding these, but this is kind of... my brain doesn't work that well, I don't think. Interesting. So okay, this is orange, so that means it can't be 4. These must be orange. Hmm. Huh. So doesn't this have to be 2 or 3? If this is 2, obviously it's 2. If it's not 2, that means this is 2, which would force this to be 2, so it's 2, 3, 4. And there's no other place for 3 in column 7. Yeah, so this is 2 or 3. This one is kind of confusing here. Hmm. Hmm. Okay. These are obviously different 8 9s. That doesn't help us much. Mm hmm. Um, hmm. Do. Hmm. This is 4 through 9. We have 4 through 9 there, but that's not really restrictive. At least not yet. This can't be 1, 3, or 4. Can't be 2, so this is 5 through 9. This is obviously all orange here. Okay, so this can never be 4, right? If this were a 4, then this would have to be 3. That would force this to be 2, and so this would be 6, 7, 8, and 9. So that would force this to be 3 and 4. I guess that could work. Never mind. So that could be 4. Hmm. Let's just try it. Okay, so if this is 4, that's 3. This can't be 2, so that's 2. This is 2. This would be 6, 7, 8, or 7, 8, 9. 3 could not be here, so 3 has to be there. This is 3 and 4. This can't be 4. 7 and 8 here, so this cannot be 7 or 8 here. 4 eliminates 4 there. No 4 here. So no 5 in these spots. 3 eliminates 3 here, so that's 4. No 4 here. This is 5, 8, and 9. So this cannot be 9. Because we'd have to have a 5 here. No 4, 5. No 4, 5. This is 4, so this couldn't be 4 there. So far this is looking fine. We have a 3, 4 pair left in row 3. Sorry, row 5. 3 eliminates 3 from being there, so this would be 3, this would be 4, that would be 3. Which would mean this is 3 here, and this is 2. Which means this can't be 2, that's 2. So this is fine. And we have a contradiction, because this digit must be greater than 5, 6, 7. So that just proves that that can't be 4. But can we do that, extend that further, is the question. So what happens if this is 2? This becomes 3 and 4. Can we extend that the whole way? So no 5 here. So we know this can't be 4, period. But 3 eliminates 3 here, so this is 3, this is 4. Again, this cannot be 4 here. No 4 along here, no 5 along here. This can't be 4. 3 eliminates 3 here, so this is 3, which makes this 3, which makes that 3, so that makes that 2, so this is 2. This becomes not 2, this is 5, 6, 7, which is less than 6, 7, 8, and 9. So that would force this to be a 4, obviously. So that's not 4. 4 can't be here, 4 can't be here, so 4 is here. This has to be a 3. This cannot be 2. This would be 2. So this looks okay-ish. No 4 here, no 4 here. This can't be 5. So we have 5 guaranteed here, and 1 out of 9. 1 out of 8 or 9. The 7 has to have 8 and 9 next to it. So this can't be 3, 8, or... This can't be 8 or 9 here. This has to have 7 or 8. Obviously no 2, no 4, no 3. So this can't be 7. No 4 here because of 4 in the column. Four has to be one of those two, so this can't be 4 here. We're guaranteed a 4 in one of these 3 cells. Cannot be the central one, because we already have a 4 in the center box. Okay. This can't be 5 because of it has to be greater than 5, 6, or 7. This could be 5. We are guaranteed in row 4, 6 or 7 has to be here. So that eliminates 6 and 7 in the rest of the box. So this is an 8, 9. Hold up. I don't think this is actually accurate now, thinking about it. You could have... No. Okay, that's right. 6 does require an 8, 9 there. So this cannot be 5. So 6 has to be below 7 and 8 or 9. 4 here would be below a 5 and an 8 or 9. And 7 has to be below both 8 and 9s. So this cannot be 5 here, which forces this to be 5 here, which cannot be next to both 8 and 9s. So it's next to 6 and 7. So this is 5, which means this can't be 5. This is 6 or 7. That eliminates 6 and 7 in the rest of the box. So this is 8 and 9. This is 6, 7 as a pair, so that eliminates 6, 7 in the rest of the column. So it's 6, 7, 6, 7 here. Okay. That seems fine. 4 can't be here, 4 can't be here, 4 is here. That forces this to be 5 there. Okay, that's fine. Four is one of these 4. Okay, so this is 4 with 8 or 9. Okay. I mean, this looks like it actually could work. Huh. So we're guaranteed a 5 here. We have 6, 7 as a pair there. This is 5, 6, 7, 8, 9. This is 6, 7, 8, 9. Huh. So this cannot be 7 or 8, so it's 5, 6, or 9. One of these two was a 5. Okay, this all looks actually kosher. Blah. I was hoping it wasn't. That's the thing. Oh, we don't have a 4 in the lower... No, we do. Never mind. Dang it. Okay, never mind. um... Hmm. Where is 5? No, 5 could be there. 4, 5, 6, 7, 8, 9. Obviously, this can't be 4. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Where is 4 in the upper central cell? It would have to be there, right? Because it can't be any of these, 1, 2, or 3. This is greater than 5. This is greater than 6 or 7. This is greater than 6 or 7. This cannot be 4 because of 4 in the column. So this would have to be 4 here, which means 4 can't be 4. So 4 has to be one of these two. Okay. Ugh. Okay, this can't be 6 because it has to be greater than 6 or 7. This can't be 6 for the same reasoning. This is 3, 4, 5, 6, 7, 8, 9. This is 4 through 9. 4 through 9. Ugh. We have upper left, upper central, upper right. We have mid left, mid mid. We do not. Okay, so this can't be 4. And mid right here. We have lower left. We do not have lower central yet, but it's one of those two then. And then lower right is one of... Okay, this can't be 4. So, yeah, that's still fine. Yeah, this is looking kosher, which is not great. Where... No, never mind. We have 6, 7, 8, 9 in the left central area. So this can't be 6, 7, 8, 9. It's 5, which forces this to be 8, 9. So this is 8, 9 as a pair, which eliminates 8 and 9 here. So that's 7, which makes that 6. That makes this 7, so it's next to both 8 and 9s. 7 eliminates 7 here, so that's 6. That makes that 7. This has to be 5. No 5 here. no 6 or 7. This becomes an 8, 9 pair, which eliminates 8 and 9 in the rest of the row. This is looking fine so far. So 5 has to be one of these two, which means this can't be 5. No 5 here. No 5 here. This cell is the same as that cell. Okay, so then, okay, let's remove coloring so that we can start coloring 8, 9 pairs. Okay, we're going to make that orange. We're going to make that yellow. They have to be opposite ones, so this can't be orange. This is yellow, which would force that to be yellow there, which would force this to be orange, which would force that to be yellow. So far this is looking kosher, fine. Orange has to be there. So this becomes an 8, 9 pair, which eliminates 8 and 9 in the rest of the row. So that's 6, 7. Yellow is here. Yellow has to be one of these two. This cannot be 8, 9, or 7. That makes this a 5, 6 pair, which eliminates 5 and 6 here. So that's 7, which makes that 6, which makes that 7. So no 7 here, no 6 here. This is 8 and 9, and it must be yellow. That forces this to be 6, this to be 5. So no 5 here, no 6. This is 9, which makes the oranges 8 and the yellows 9. Interesting. This then has to be 7. This is 6. This is all looking kosher. So this is 3. Not 3 here. This is 8. This is 3. 6 or 7. 6 or 7. 5 eliminates 5 here. Yeah, this is looking kosher. But anyways, no 9 here. No 6 or 7 here. No 3 here. No 9 here. 4, 5, and 8. No 9 here. 7 eliminates 7 here. So this is 6. This is 7. That makes this 7. No 7 or 9. Well, these are consecutive and cannot have an 8. No 6 here, so no 6 there. So 4, 5. Okay. 7 forces this to be 6. So this cannot be 6. To be consecutive, this cannot be 5 then. This has to be 8. So 8, 7, and then this has to be 9. 5. This is looking like the solution. 8. No 8 here. This is 5 and 6. This is then 4 and 5. Yeah, this is looking like the solution. Wow. Went down all that way, and it's like, oh, we are not contradicting ourselves. Oof. So then we have to try the other way and see where we can find a contradiction there. There's probably a much better way of doing this, but I don't know what it is. So, this is the only way that I'm going down. Huh. Yeah, there's probably some elegant way of disproving the other path. I don't know what it is, though. Let's just go down and see what happens. So that was if that was 2. So if it's not 2, this is 3. So then this is 2. This becomes 2 here, 3 and 4. No 3 and 4. 4 cannot be... This has to be greater than 5 or 6. So no 4 or 5. Where is the 4 in column 7? It has to be here. So this is 5 through 9. 5 through 9. Okay. That means this can't be 3. Where is the 3? It has to be here. So this can't be 3 there. No 3 here. This has to be 3 here. And this could be 4 through 9. No 4 here, so one of these is, well, okay, so this obviously. 3 cannot be here and cannot be here, so 3 has to be here. Okay. 3 can't be here. So 3 is one of these two, 3 is one of these two, 3 is one of those two. We have to have a 4 be one of these cells there. This cannot be 4 here. So 4 is one of those two. 4 is one of those 3. This is 5 through 9. Obviously no 3 there. We don't have a restriction here. It could be both 4 and 5 there. So that doesn't restrict anything else. 4 eliminates 4 in the upper left-hand cell. So this cannot be 5. This is 6, 7, 8, and 9. So this is either 3 or 5, 6, can't be 5. 3 or 6, 7, 8, and 9. Because if it's 2 here, this has to be 3. If it's 5 or 6 or 7, obviously it has to be 6 through 9 there. We have 4 through 9 here. Not helpful. This is greater than 4, so this can't be 4 here. Where is, well, 4 could be here. 4 through 9 there. Ah, cannot be there. So 4 eliminates 4 from being there. Where is the 4 then in box 8? It has to be there, which eliminates 4 from being here and here. Ah, we need a 4 in the left central cell. Cannot be here in column 7, can't be here in column 6, cannot be here in column 1 then either, because again, if we have a 3 here, if we have tried to have a 4 here, that would mean this is 2, but then we need a 3 in also in the left central cell. So this is the contradiction that we get. That's tough to see, to spot that. I don't know how you spot that without that, right? This can't be 4 because it has to be greater than 5, 6, or 7. And anytime you have a 4, it would have to be next to a 2. So I don't know how you spot that contradiction. It does lead to it, so there is that. So then now we can solve it the way that we were solving it. And that we know that the other way leads to a contradiction. So, but I don't know how you spot that. That's really tough to spot. Anyways. So this cannot be 3. This has to be a 2. So this is 2, which forces this to be 3 and 4. No 4 here. That means these can't be 5 to be greater than the 5, 6, or 7. This can't be 2. Since this can't be 2, this is 2 here. This can't be 3 here. That forces this to be 3 here, which means this can't be 3. So this is 4 here. These can't be 3. This can't be 3. So 3 has to be here. 4 eliminates 4 here. It cannot be an 8-9 pair, because if this were just 8 and 9 as a pair, the 7 in that position has to have an 8-9 surrounding it. The 6 has to have a 7 and 1 out of 8 or 9 surrounding it. So that means this has to be 5 with 8 or 9. So this cannot be 4, 5, no 4, 5. That means we have the 7 having both 8, 9s surrounding next to it in the box. 6 has to have a 7 and one of the 8 or 9 surrounding it, so these cannot be 8 or 9. Therefore, this cannot be 4, 5, 6 or 5, 6, 7 as a Renband, because that would eliminate 3 possibilities from these cells, which would mean these are the same digit. So that doesn't work. This can't be 4, so these cannot be 5 to surround it. This can't be 2, obviously. So this has to be either 6, 7, 8 or 7, 8, 9, which means these can't be 7. So these have a 4 surrounding it. 3 is one of these two. Remaining digits here are 5 through 9. This can't be 4. No 4 here. Okay, so then this is 3. How did we prove this? Okay, so, these can't be 3. That's the reasoning. So these can't be 3 because of this 3, so this must be 3 here, which eliminates 3 here, which makes this 3. Since this can't be 3, this can't be 2, because this has to be 3 here, which means it's only greater than 2 there. So therefore, we know this is 2. This 5, 6, 7 can only have 6, 7, 8 surrounding, 6, 7, 8, 9 surrounding it. We have a 5, 6, 7, 8, 9 quintuplet, so this can't be 5, 6, 7, 8, 9, it's 4, which eliminates 4 here. Whereas the 4 in column 7, it has to be here. That eliminates 4 here. Okay, we have all the 2s now. 3s. We have 7, so 3 is one of these 2. 3 is one of those 2. 4. We have 4 in all 3 positions in the left position. Central, okay, so this is 5 through 9. 5. Okay. So how did we do this? 4 can't be here and can't be here because of 4 in the column and row, so 4 has to be here. That eliminates, so this is 4, 6, 7, 8, 9, or 5, technically. How did we get this away? Right, we had a 6, 7, 8, 9 quadruplet in the left central disjoint positions, which eliminates 6, 7 through 9. So this can't be 6 through 9, it's 5, which means this can't be 5. That means this can't be 5. This has to be 6, 7, 8, 9. We have 5 through 9 here. This is 5 through 9 here. 4 through 9 here. 4 through 9 here. This can't be 4 because of 4 in the row. This could be 3, though. We have 4 through 9 here. 4 can't be here. 4 is one of these 2, which means this can't be 4 here. So remove the oranges. Where is 4 in the upper central position? So we have 6, 7, 8, 9 here. 8, 9. That eliminates 6, 7, 8, 9 in the rest of the upper central positions. So this can't be 6. This is 5. This can't be 5 through 9. It's 4. That eliminates 4 from being here. And that can't be 4 here. So one of these 2 is 4. 4 cannot be in the central position, so that's not possible. Okay. We have an 8, 9 pair. That's it. So this is 8, 9 pair in row 5, which eliminates 8 and 9 in the rest of the row. So this must be greater than that. So okay, so this is 8, 9. Again, we mark this as orange. This must be yellow here. Because these have to be different cells because of disjoint set and the Renband. So this can't be orange, this is yellow. This is 5, 6, 7. This cannot be 6 or 7. It's 8 or 9. 5 cannot contain... So 7 has to have both 8 9s around it. 4 has one other 8 9, and the 6 must have a 7 and the other 8 9 around it. So since this is the other 8 9, it cannot be 5 here. Therefore, this is 6, which makes this 7, that 5. None of these can be 6, so that forces this to be 5 here. 5 cannot have 8 or 9 surrounding it because we have 1 here, we have 1 here. 7 has to have both 8 9 surrounding it. So this is yellow, that makes this orange, which makes this yellow. So this cannot be 7, 8, or 9. 6 cannot be below the 7, so this is 8, 9, and is the yellow, 8, 9. This can't be 8, 7, 8, or 9, it's 6. This cannot, we have, this is yellow here, so this must be the orange, 8, 9, and this 8, 9 pair eliminates 8 and 9 in the disjoint set, so that's 7. This cannot be 7. This is yellow, 8, and 9. So this cannot be 5, 6, or 7. It's 4, 8, and 9. This is yellow, 8, and 9. We have yellow, 8, 9, yellow, 8, 9. So this cannot, this 8, 9 pair eliminates 8 and 9 in the rest of the column. This can't be 8 or 9 or 7. So that makes this 6. That makes that 5. No more 5 here. This is then 6, 7, and 8 to be a Renban. So this has to be 9 here. So 6 eliminates 6 in the rest of the row. This is 9, which means all the oranges are 8s. And all the yellows are 9. So this is yellow as a 9. 8 eliminates 8 here, so it's 7 and 8. This can't be 7, 8, or 9. It's 6. No 6 or 8 here. It's 7, 9 as a pair. 6 eliminates 6 here, so it's 7 and 6. These can't be 9 anymore. Cannot be 9. So it's 3 as a pair. 7 eliminates 7 here, so it's 9 and 7. 8 eliminates 8 here, so it's 9. This cannot be 6, 7, or 9. So it's 5 or 8. That eliminates 5 and 8 in the rest of the box. This can't be 4 because of 4 in the box. This 9 eliminates 9 here. This can't be 5, 8, or 9, so it's 6, 7 as a pair. This 5 eliminates 5 here, so that's 3. 3 eliminates 3 here, so it's 8 and 3. This must be 6, 7 as a pair, and 6, 7, because those are the only possibilities left. This 6, 7 pair eliminates 6 and 7 in the rest of the box. This can't be 3. So no 7, and then no 6 here. 9 cannot be here in the box anymore, so this is 4, 5, 8. This can't be 7 or 9. This can't be 9. This can't be 9. It's 4, 8 as a pair. Where is, well, we don't know. This is 9, so this can't be 9. That's 7, which makes this 6, which makes that 9, which is consecutive with 8. So that's 8 and 5, which eliminates 5 here, so that's 8. 7 eliminates 7 here, so that's 6 and 7. These cannot be 8 still. 6 eliminates 6 here, so that's 7. No more 7s available here. And no more 6s available here. Let's see. We have 8 can no longer be on this Renban because it's only consecutive with 7 or 9. 8 can't be here. Where is 8 in box 2? It has to be here. So this is 8, which makes this 4, which makes that 8. 4 eliminates 4 here. This is a 5, 6 pair, which eliminates 5 and 6 in the rest of the box. So this is 4, which makes this 5, which makes that 4. 4 is only consecutive with 5 out of 5 or 6. So this is 5, that's 6, which makes this 5 and 6. Oops. I must have messed up. Dang it. Where did I mess up? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Oh, we have 2 9s. That's why. So this is 8. Wow, that was pretty crazy. Yeah, I'm not sure how to disambiguate this part here. Yeah, I guess you just have to try it. You have to try one of them and say what happens if you go down that path, right? Execution-wise, definitely very hard, so... The logic behind it wasn't very hard difficulty, but probably still hard. A lot of really cool logic, though, with the disjoint sets. That was actually very interesting. And that's part of what I was attracted to it, because I was just like, oh, this is disjoint sets. So, I like disjoint sets a lot. I can spot them where a lot of people can't. Some people talk about like how they have trouble seeing them, but for some reason I can spot them better. But it's the exact opposite for me with anti-knight move, because I can't spot anti-knight to save my life. I don't think. I'm better at it now that I've tried some of them, but I still don't really enjoy it because I can't spot them. But disjoint sets, for some reason, it just works with my brain pretty well. So I can spot them fairly decently, but I don't know how you spot this one with the minimums. I guess you have to spot that basically the 3 and the 4 have to be in the left central position somewhere. And if you have this being the 3... But the thing is, I don't know. Yeah, it's just confusing to me. I don't know. I just went down the path because that's easier than trying to sort of think about the theoretical way of actually solving that versus like just try it out, right? Sometimes trial and error is the best way, best method. Unless you can come up with a very clear, crystallized version of the solution. But anytime you solve one of these, I don't know. I don't think in theoretical ways that well. So if that were the case, well, that's maybe why I went more down the path of the engineer, where you basically have to build something, and it's easier sometimes just to trial and error that through, and say, hey, I'll try this, and if it doesn't work, we try some other method, right? Yeah, so maybe the theoreticians would be better at being able to solve this, like, clearly. For me, sometimes it's just a lot of trial and error. It's just like, oh, well, logically, this doesn't work. But once you get past a certain logic, you just have to try things out, I think. I don't know, it's sort of the old, there's been sort of, I don't know. A lot of people in the variant Sudoku community don't like bifurcation. I can understand. It's like there's an elegance of finding things theoretically. But I guess I'm too engineer-like, where I basically say, hey, just try it out. And just try things out and see if it works. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.